Hello CT students. You must have seen the lecture by the professors on nested iterations, where they use the naive approach and the binning approaches. So there they were trying to find out a common birth date in this course data set. In this tutorial, we will look at a very similar task where we try to find scorecards with the same mathematics score from the same place. So this is the data set as you know. Since we only need these two fields in particular, let's look at a more focused version of this dataset along with the pseudocode. So here this is the pseudocode and we are looking at the scorecard dataset here. We now begin with initializing the count variable to 0 and there is this table 1 which is here and there's also a mention of table 2 and table 3 which are placed below table 1. Now let's begin. Count has been initialized to 0 while table 1 has more rows. So table 1 has rows now. Read the first row x in table 1. So this would be the first row x in table 1 and move x to table 2. So we take this and we go off to table 2. After this is done, while table 1 has more rows. So are there still more rows in table 1? Yes. Read the first row y of table 1. So this is the first row y of table 1. And if x dot place is equal to y dot place. So y dot place here is Salem, x dot place is Erode. So they're not equal. This entire AND condition is not satisfied. So we don't get inside this if block. After that, what do? We move y to table 3. So this is our y and we are moving it off to table 3. And now we go back to this part while table 1 has more rows. And again we do the same thing here. The next row is this. Chennai is not the same as Erode. So we move this off to table 3. And we keep doing this in this way. Again a Chennai, not Erode. So move it off to table 3. Now Madurai. So moving it down. Now another Chennai. So moving it down. Now Ambur. So move it down. Now Vellore. Move it down. Bengaluru. So move it down. Again Bengaluru. So move it down. Chennai. Bengaluru. Chennai. Madurai. Trichy. Theni. Trichy again. Chennai. And now we have a situation where x dot place and y dot place are the same. This is an Erode card. And then we look at the second part of the AND statement, which is x dot mathematics and y dot mathematics, are they equal? X dot mathematics is 68, y dot mathematics is 72. They are not equal. So we don't do anything again. We go on to the next line of code, which is to move this card to table 3. Now Trichy. Vellore. Bengaluru, Nagarkoil, Bengaluru again, Madurai again, Chennai, Chennai, Madurai, Madurai, and Vellore. So now table 1 is empty. So this condition is not satisfied. We are now out of the while loop. Once we are out of this while loop, we now go to the next line of code, which is move all rows from table 3 to table 1. So we empty table 3 and move it all to table 1. So here now they are all back in table 1 and table 3 is empty. And after that, while table 1 has more rows, so table 1 again has more rows. Now again read the first row X in table 1, which is this one, and move it to table 2. So we have moved it to table 2. Now X is this row. X dot place is Salem. So we again do the same procedure of taking each row, looking if it is Salem or not. And as you can see, none of these is Salem. So one by one we drop off these rows into table 3. Now table 1 is empty again, so we move all these rows back to table 1. Now again the first row X in this table is this, where we have Chennai as the place. So this is our X dot place. And then we start looking here. This is Chennai. So we now verify if the math score is same. This is 57, this is 42, so they're not same. So we move this row down. Now the next one is Madurai. And now again it is a Chennai. And the mathematics score is 71, which is not equal to 57. So this also goes down. And here we have a Chennai again. And the mathematics score is 64, which is not 57. So this goes down too. This is a Chennai again. Mathematics score is only 52. So this goes away. Now another Chennai and mathematics score is 62, not equal to 57. So this goes down. Here we have a Chennai again with mathematics score 87, not equal to 57. And again Chennai, but 74. Now table 1 is empty, so we move all the rows from table 3 to table 1. And now we have, this is our row X, and we bring it down to table 2. Here the place is Chennai and math score is 42. So let's begin again. Now the place is Chennai, but math score is not 42. Now here the place is Chennai, but math score is not 42. Here the place is Chennai, but the math score is not 42. Chennai again, math score is not 42. Now this is Chennai, but math score is not 42. Again Chennai, but not 42. So now table 1 is empty. We come out of this particular while block and we move all these rows again back to table 1. Now this is row X, which we move to table 2. Place is Madurai, math score is 87. Going back into this while loop. Now we have a Madurai, but math score does not match. Here is another Madurai, but math score is not 87. Another Madurai, but math score is not 87. One more Madurai, but math score doesn't match. Table 1 is empty. So we move all the rows from table 3 to table 1. Now row X is this, which we move to table 2. The place is Chennai. The math score is 71. Here it is Chennai, but not 71. 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 Table 1 is empty now. So we move all the rows from table 3 to table 1. Now this is our row X, which we move to table 2. The place is Ambur. The math score is 81. So now table 1 is empty, which means there's only one Ambur card. Anyway, now we move all the rows from table 3 to table 1 again. Now our row X is this, which we carry down to table 2. It's Vellore 84. Here this is a Vellore, but the score is not 84. One more Vellore, but the score is not 84. And table 1 is empty. So we move back all the table 3 rows to table 1. Now this is our row X. Just take into table 2. Bengaluru 74. This is a Bengaluru, but the score is not 74. Again Bengaluru, but not 74. Again Bengaluru, but not 74. Bengaluru, but not 74. No more rows in table 1. So we move table 3 rows back to table 1. Now this is our row X, which is being carried to table 2. This is Bengaluru 63. This is a Bengaluru, but not 63. Bengaluru, but not 63. Bengaluru, but not 63. Table 1 is empty. So we move these rows back. Now this is our row X. Let's move to table 2. It's Chennai 64. It's Chennai, but not 64. This is Chennai, but not 64. Chennai, but not 64. Chennai, but not 64. Table 1 is empty. So bring all these rows back. This is our row X now. We move it to table 2. It's Bengaluru 97. This is Bengaluru, but not 97. Now this is Bengaluru, and the math score is 97, which is identical to our card X here. So this is common, and we finally enter this portion of the code where we increment count to 1. So we found one pair of cards with same place and same mathematics score. And then we get back to the same business of moving this down. Table 1 is now empty. So we carry these rows back to table 1. This is our row X now, which is being carried to table 2. This is Chennai 52. This is Chennai but not 52. Again Chennai, not 52. Chennai but not 52. Table 1 is now empty. So we go to table 3, pick up all these rows and again take them to table 1. This is our row X now. We carry it to table 2. We drop it here. In table 2, it's Madurai 65. Another Madurai but not 65. Madurai but not 65. Madurai but not 65. So table 1 is now empty. So again we carry table 3's rows and drop them over there. Now this is our row X, which is moved to table 2. It's Trichy 89. Now this is Trichy 87. It's not 89. It's Trichy, not 89. Table 1 is empty, so we again pick up these rows from table 3 and carry them up. Now this is our row X. We drop it in table 2. This is Theni 76. Table 1 is empty again. There was only one Theni card then. There are no Theni cards otherwise. Now we take these rows and go drop them here. This is our row X now. It's Trichy 87. It's Trichy but not 87. Table 1 is empty again. We carry these rows, drop them there. This is row X now. This is Chennai 62. This is Chennai but not 62. This is Chennai but not 62. Table 1 is again empty. We pick up these rows, drop them here. This is row X now, which is E Road 72. Table 1 is empty again. These rows go up. This is row X now, which is Trichy 56. Table 1 is empty. This is our row X now, which is Vellore 93. Now this is Vellore but not 93. So table 1 is empty. This is row X, Bengaluru 78. This is Bengaluru but 97, not 78. Table 1 is now empty. Bring back these rows from table 3. This is our row X now. That is Nagarkoil 62. Table 1 is empty. Bring these back. This is our row X, which is Bengaluru 97. Table 1 is empty. So bring back these. This is our row X now, which is Madurai 44. This is Madurai but not 44. Again Madurai but not 44. Table 1 is empty again. This is row X, which is Chennai 87. This is Chennai but not 87. Table 1 is empty again. This is our row X now, which is Chennai 74. Table 1 is empty again. This is row X now. That is Madurai 81. This is Madurai but not 81. Table 1 is empty again. We're bringing back these rows. This is row X now, which is Madurai 74. This is Vellore. So it goes to table 3. Now table 1 is empty. So we are out of this block. We have to do this line of code now, which is carrying back this row here. And now while table 1 still has rows, table 1 has one row, read the first row, which is this is our row X, move it to table 2. And now, while table 1 has more rows, is not satisfied. Table 1 is now empty. So we just come here and we also see that table 3 is also empty. So we go back to the top, which again checks whether table 1 has more rows. It does not. So we're out of this while loop and this code is done. And we have done a lot of iterations. We've done overall 435 comparisons. That would be 30 into 29 by 2, according to the formula used by the profs. Now let's look at what happens in binning. Now here we are going to try the binning approach, and we are going to bin according to the place. So all rows of one place will be binned together. And this is a pseudocode for that. And here we see these various tables, table Ambur, table Bengaluru, table Chennai, etc. So all these tables we have placed them under table 1, which are like this. And what this code tells us to do is, while table 1 has more rows, so we go through table 1, pick row by row, read the first row, X in table 1, so we pick row by row, and then if depending on X's place, we move it to that corresponding table. So let's do this one by one now. Here this is our row X now, this is E road, so we take it to E roads table. So that is in table E road. And likewise, this goes to the Salem table, this goes to Chennai table, again Chennai table, Madurai table, Chennai table again, Ambur table, table Vellore, table Bengaluru, Bengaluru again, Chennai, Bengaluru again, Chennai, Madurai, Trichy, Theni, table Trichy, Chennai, table E road, table Trichy, table Vellore, Bengaluru is here, table Nagarkoil, one more Bengaluru, Madurai table, Chennai table, table Chennai again, one more Madurai table, and one more for table Madurai. And lastly, we have one for table Vellore. Now table 1 is empty. There are no more rows. So we are out of this while loop. So binning is over. There is nothing outside of this loop for us now. And now, once the binning is done, for each of these tables, we run this code, which is pretty much identical to what we had done with table 1 earlier. Here, however, we run it for each city table. So we run it for table Ambur, we run it for table Bengaluru, we run it for table Chennai, so on for every city table. The code is very much the same. You read the first row X in that particular city table, you move that row to table 2, and while that city table still has more rows, you read the first row in that city table. And here the only difference is, in the if condition we don't have an AND statement, because we no longer need to check for the same place, because every row in that particular city table will have the same place. So we're only checking for mathematics scores, and in case they're equal, then we increase the count. And after that, we move this Y row to table 3, and finally all table 3 rows are moved back to the city table. So this way, this code is very, very much identical to what we had done earlier, except now we do it city by city. So we can now look at the number of comparisons it's going to take. For that, let's look at how many rows are there per city. So here we see the number of comparisons that we do per city. So per table, how many comparisons comes out? And this goes with the formula n into n minus 1 by 2, where n is the number of rows in that particular table. So Ambur has only one row. So you will get 1 into 0 by 2, which is 0 comparisons. Bengaluru has 1, 2, 3, 4, 5, 5 rows. So you get 5 into 4 by 2, that is 10. Chennai has 1, 2, 3, 4, 5, 6, 7, 8. So 8 into 7 by 2, which is 28. And Erode has 2, so 2 into 1 by 2, which is 1. Madurai has 5, so 5 into 4 by 2, which is 10 again. Nagarkoil is a single row table, so you'll get 0 comparisons. Salem has 0 comparisons. Theni also has 0 comparisons. Trichy, there are 3 rows, so 3 into 2 by 2, which is 3 comparisons. Same with Vellore, 3 rows, 3 into 2 by 2 is 3 comparisons. And the total number of comparisons is now only 55. Earlier in the table 1, we had done 435 comparisons overall. So this way, binning drastically reduces the number of comparisons if the data is reasonably distributed across various bins. As the professors have indicated, if all the rows were to go into one table, suppose everybody is from the same city, then you will again have to do 435 comparisons. But here they are quite distributed, therefore we have gotten much lesser number of comparisons. Thank you.